Okay, now there is a note to remember. Okay, you have to remember these following points. Number one, if a function f is increasing, okay, if a function f is increasing, then this f dash, okay, f dash will be greater or equal to 0. Then next one, if a function is strictly increasing, you can write here f dash x, okay, then this f dash x will be greater than 0. Okay, third one is if a function if a function f, okay, then here also let us consider f of x. If a function f of x is increasing, then f dash x will be greater than 0. And if a function, here also let us consider f of x is strictly increasing, then f dash x will be greater than 0. Next, if a function f x is decreasing, then f dash x will be less or equal to 0. And then the last one, if a function fx is strictly decreasing, then f dash x will be less than 0. Okay, so these are the 4 points that you have to keep in mind, okay, for doing the exercise. So now let us do exercise 6.2, question number 1. Show that the function given by f of x equal to 3x plus 17 is strictly increasing on R. So here we have to show that this function f of x is strictly increasing on R. So the condition for strictly increasing is if f of x, okay, is greater than 0, then we can say that the function is strictly increasing. Okay, so we have to find f dash x. So here f of x is given 3x plus 17. Now we have to find f dash x. F dash x means the derivative of fx. Okay, so if you differentiate this 3x, you will get only 3, right? And if you differentiate 17, constant term, you will get 0. So we are getting f dash x equal to 3. So it is greater than 0, right? And the condition is satisfied. So you can write, since f dash x is greater than 0, therefore f of x is strictly increasing on R. Okay, let us do question number 2. So question number 2 is show that the function given by f of x equal to e to the power 2x is strictly increasing on R. Strictly increasing on R. R means real number. So here also same thing. If we can show that f dash x is greater than 0, then the function is strictly increasing. So here f of x is given e to the power 2x. So we'll find f dash x. So derivative of, you can differentiate also, ddx of e to the power 2x. So differentiation of e to the power 2x is e to the power 2x into, and then differentiation of 2x is 2. So we'll get 2 e to the power 2x. Okay, this is our f dash x. Now whether this value is greater than 0 or not, that you have to check. See, the value of e is something 1.78. okay, that means it is positive. Okay, so for example, if you put here 2 in place of e, if you put 1.78 to the power 2 and x, here it's a real number, right? So it might be positive or negative. So suppose if you put a positive number, say 1 or 2, that means 2 into 1.78 to the power 4. So the answer will be in positive, right? That means greater than 0. Suppose if you take negative now, say for example you are taking 2 into the value of e is 1.78 to the power 2 into say minus 2. So this answer will get in 2 into 1.78 to the power minus 4, right? So this part we can write like this: 2 into 1 by 1.78 to the power 4. Yes or no? Minus 4 we can write like this in the denominator, so it will become positive. So we are getting a positive number, right? That means we can say that f dash x is greater than 0. So we can write, since f dash x is greater than 0, so therefore this fx is strictly increasing on r, real number. Okay.